So PV modules are made from semiconductor material, which have the ability to convert the sunlight into electricity. And the most common PV modules material are polycrystalline, monocrystalline, and thin film. So for the first one, monocrystalline solar panels, these are made from silicon, which has a high power output and occupy less space and last long. And we could recognize them by the uniform dark look and the round edges. When it comes to the cost, it is the most expensive solar modules. The second type is polycrystalline solar panels, which are made also from silicon, but the difference is that the process to make these solar cells are less complicated than the monocrystalline. So it has a lower efficiency when compared with monocrystalline and occupy more space. We could recognize them by the square, by its square shape, which has a blue color and spec locked. It's an expensive option, but as we said, it is less than the other monocrystalline solar panels. The third type is thin film solar cells, where they are made from a photovoltaic material such as silicon, cadmium, or copper. Actually, different layers are putting together to form this thin film. So they have the lowest efficiency and occupy more space, but they have an advantage that they are less affected by high temperature. These are some of the types of these thin film solar cells, like the cadmium telluride, amorphous silicon, copper, indium gallium selenide, and gallium arsenide. In terms of cost, they are the less expensive solar cells. So most of the PV panel, they have the same construction. We have the frame, and we have the glass cover, and then we have polymer sheets and front and back of the solar cells, and then we have the backing material. So solar cells, they are connected in series. Each module, it has more than 60 to 72 number of cells, and these are connected in series. So we see that the front contact is connected to the back contact of the other cell, and key for the other cells in the module. And here is a cross-section view of these PV panel, and we see that we have the glass, and then we have the anti-reflection coating, we have the electrical contact, and then these are the silicon layers, and then we have the back electrical contact, and then the polymer back sheet. So silicon, it has 4 electrons in its outer shell. So in order to, let's say, excite these silicon, we need to dop it with another material, like arsenide here, or a boron and the p-type modules, or p-type silicon. So PV panel specification, it comes with a term called STC, or standard test condition, and this means that these panels, or the values indicated on the panel, is based on 25 cells temperature and 1000 watt per meter square and 1.5 air mass. There is another term which is called NOCT, which is the normal operating cell temperature, and here this gives more realistic condition to the let's say real world, like the temperature, or the air temperature is 20 degrees Celsius, and the wattage is 800 watt per meter square. So both of these, we will find them on the let's say technical data sheet for a PV modules. Here are some other values that will be indicated on that PV panel or data sheet. the nominal voltage, open circuit voltage, short circuit current, maximum power point, maximum power point voltage, and maximum power point current. So in this graph, actually, we see all of the aforementioned, let's say, items, like the short circuit current. We find this is the short circuit current, which is the maximum current of the modules, and also we see here the open circuit voltage, which is the maximum voltage when the current is 0. And here we have the maximum power output of that module with their corresponding voltage, maximum power point voltage, and its corresponding maximum power point current. And these are the different curve or IV curve under different insulation levels. Here is an example of nameplate of a module from SunPower manufacturer, and we see that it has rated power and also its maximum voltage and maximum current, open circuit voltage and short circuit current under the STC condition as we mentioned. So PV panel are arranged in cells, and different cells connected in series to form the modules, and the connection of different modules and series will form a string. Connection of strings in parallel will form the array. So the array is basically a combination of series and parallel connected modules.